Hello everyone. In this video, we are going to discuss about two questions which were asked for the JEE examination in the previous year and from the chapter Electrostatic Potential and Capacitance, second chapter of class 12 physics. See, we have already discussed about many other JEE questions which were asked from the same chapter. You will be getting all those videos from the playlist. So let us move on to this question. See, in this video we are discussing two JEE questions. So let us see the first question. Two capacitors C1 and C2 are charged to 120 volt and 200 volt respectively. It is found that by connecting them together, the potential on each one can be made 0. Then 4 options are there. Which one is the correct option? See, this is a question which was actually asked for the JEE main examination 2013. So let us see its solution. So there are two capacitors C1 and C2. So let us take C1 as the capacitance of the first capacitor and C2 as the capacitance of the second capacitor. C1 is charged to 120 volt. So I am taking V1 equals 120 volt. And C2 it is charged to 200 volt. So I am taking V2 as 200 volt. Then you see it is found that by connecting them together, so we are connecting these two capacitors together, it can be connected in series and it can be connected in parallel as well, no? But here they haven't given us in which way these two capacitors are connected. It is given that by connecting them together, the potential on each one can be made 0. So you see, for potential to be made 0 after connection, the charge of both capacitors are equal. Okay, so if we are connecting the two capacitors in such a way that the potential is 0, then that time the charge on both the capacitors will be equal. So I am taking the charge on the first capacitor as Q1, charge on the second capacitor as Q2. So Q1 will be equal to Q2 in this case. Now you see, we have this equation which is relating the capacitance C, charge Q and the potential V as C equals Q by V, no? Okay, from this equation we can write charge Q equals C into V, or charge small letter Q equals C into V. Okay, so you see this Q1 can be written as what? C1 V1 equals Q2 can be written as what? C2 V2. Okay, now C1 into what is the value of V1? 120 volt. Okay, equals C2 into what is the value of V2? V2 is 200 volt. Alright, now I am taking this 120 volt to the other side of the equation. So C1 equals C2 into 200 volt divided by 120 volt. So you see volt cancelled, 0, 0. Okay, then 10 2s are 20, 6 2s are 12. Okay, 5 2s are 10, 3 2s are 6. So here you have C1 equals C2 into 5 divided by 3. Now I am taking this 3 to this side of the equation, that goes to the numerator. So it becomes 3C1 equals 5C2. Okay, so which one is the correct option? 3C1 equals 5C2. So option B is the correct option. Now let us discuss another question which was actually asked for the JEE main 2013 examination from the same chapter Electrostatic Potential and Capacitance. See the question. A charge Q is uniformly distributed over a long rod AB of length L as shown in the figure. So you see there is a rod AB of length L. A charge Q is uniformly distributed everywhere along this rod AB. Now the electric potential at a point O, this is the point O, lying at a distance L from the end A is dash. Okay, so you see this end is A. From the end A length L is marked here. Then the point O is marked here. So we want to determine the electric potential at this point O due to this charge distribution. See, we know the expression for the potential V due to a charge Q at a distance R as V equals 1 by 4 pi epsilon 0 Q by R. So we are going to make use of this equation here to solve this question. Okay, so to get the potential at this point O due to the charge distribution Q along this rod AB, what I am doing is I am just considering a very small line element or line segment. Okay, I am taking a very small line segment of length dx of this rod AB. See, this length dx of this rod AB, that will contain some charge. I am taking the charge as dq. See, q is the total charge which is distributed everywhere on this rod AB. I have taken a very small line segment dx. Okay, dx is the length of this line segment which is having some charge dq in it. Okay, then I am taking the distance to this point q from the small line segment as x. Then what I am going to do is I am going to find out the electric potential at this point O due to the small line segment first. Then after that I will be integrating that so that we will be getting the total electric potential due to this all charge distribution at this point O. Okay, so here the potential at O due to the small line segment dx of charge dq at a distance x can be written as what? dv equals. Okay, because there is only a very small potential due to the small line segment, no? So I am taking that potential as dv. So dv equals 1 by 4 pi epsilon 0. Okay, the charge present here is dq. So dq divided by, see the distance here is x. So dq by x. See, we have this expression for the linear charge density lambda as lambda is equal to linear charge density lambda equals charge per unit length. Okay, so that we can write the total charge Q as the linear charge density lambda into length L. So, we are applying this equation to the small part. Okay, so you see the charge on the small line segment, that is dq. So we can write dq equals linear charge density lambda into length of the small segment is dx. Okay, now this can be written as dq equals, see what is this lambda? This lambda is q by L, charge per length. So q by L into dx. Okay, so I am going to substitute this expression for dq here in this expression. So, this expression dv, this can be written as what? 1 by 4 pi epsilon 0 dq by x. This dq is replaced with q by L dx divided by x. Okay, now you see this is the potential at this point O due to this very small line segment dx of charge dq, that is dv. See, we want to find out or we want to get the total electric potential at this point O due to this all charge distribution Q. Okay, so the total potential V will be, we can find that V by integrating this small potential dV. That is V equals integral 1 by 4 pi epsilon 0 Q by L into dx divided by x. And you see, this integration will have a limit, a lower limit and an upper limit. You see the integration variables dx, that is x, which is the distance measured from this point O. See, the charge is distributed everywhere uniformly along this rod AB. So we have to consider this end of the AB as well as this end of, the rod. That is, we have to integrate it from this point to this point. Okay, so you see, x is the integration variable here, which is the distance measured from this point O. So, from the point O to this end A, the distance is L. Okay, then from the point O to this end B, the distance is L plus L. Okay, L OA, that is equal to L. AB, that length is also L. So from the point O to this point A, the distance is L. From the point O to this end B, the distance is L plus L, which is 2L. So lower limit L, upper limit 2L. Now this is equal to what? I am taking this 1 by 4 pi epsilon 0 outside of the integration, Q by L as well outside, integral L to 2L 1 by x dx. Okay, that is the total potential V equals 1 by 4 pi epsilon 0 Q by L. Integral 1 by x dx is actually what? The derivative of log x is 1 by x. So, integral of 1 by x is log x. So, log x within the limits L to 2L. So, this becomes equal to what? 1 by 4 pi epsilon 0 Q by L. Then we have to apply the limits, upper limit minus lower limit. So, this becomes log 2L minus log L. So, this becomes equal to V equals 1 by 4 pi epsilon 0 Q by L. Then log A minus log B, which is log of A by B. Okay, so log A by B, that is log 2L by L. Okay, this L get cancelled, so that this can be written as 1 by 4 pi epsilon 0 Q by L into log 2, or this can be written as Q by 4 pi epsilon 0 L into log 2. So this is the answer. So in this video, we have discussed about the two previous years JEE questions asked from the chapter Electrostatic Potential and Capacitance. You will get all other questions asked from the same chapter as well as from the otherwise chapter. That is, chapter wise questions are available, which is available in the playlist. So you can just go to the playlist and you will get all other, the solutions to such, the questions asked for the JEE exams, NEET exams, etc. chapter wise. So thank you.